Alright, friends, now we are going to see how electricity is being generated, and we are going to start with the basic things first. So, to be uh, to be familiar with the basic things is that when electricity is being generated, it's the charging of the material. So, when a material is charged, it is generating a potential difference. This potential difference is voltage. Voltage is measured in volts. For example, if one metal rod is charged with electricity, this rod is having some voltage and current in it. Voltage is charged electrons finding a space to travel to settle down. You can charge material in six different ways primarily. There are so many methods, so many tricks and tips to charge any material, but these are the basic ones. And the one in which we all have interest is the chemical reaction system, which is through battery. Why we all are having some interest in it? Because all the cars, even now, even in aviation as well, we are thinking about to to make use of this system, chemical reaction, because we are now thinking about to fly our planes with the fuel cell system. So in fuel cell system we need chemical reaction based electricity, which is primarily a battery system. And then the second one is the light, which is our PV solar cell system. And now this uh, PV solar cell system is, uh, we all know that it's the solar system. And again, if we are using this system, we need battery to use this power. Third, we have electromagnetism. Electromagnetism is the generator or dynamo system, which I have seen many times in developing countries. What they do is they fit a dynamo on their bicycle, and when they ride their bicycle, it generates some electricity to give power to their light bulb on the handle of their bicycle, so that they can ride their bicycle in the night time as well. Then the third is thermocouple. Thermocouple is also used in a variety of industrial applications, and in conveying or in giving us the temperature of our exhaust systems in our automobiles, to switch on or switch off some of the and sensors and electrical systems. Friction is the static electricity. Uh, it is also seen when we are working on our electrical systems. We must ground them so that we don't fry our ECMs. And then the next one is our pressure piezoelectric generator. These ones are also used in many industrial applications. Now, current. Current is the is amount of charged electrons. When this amount of charged electrons goes down, voltage goes down. So, as we have discussed earlier, that the voltage is the potential difference. It's the potential difference between charged electrons and uncharged electrons. So current is the amount of the charged electron. So when you have seen that when the amount of charge in a battery goes down, it's actually what we measure is the voltage. So voltage is the amount of charged electrons. So when the electrons they they travel through to the battery and it goes out of the battery, the voltage starts going down. So this is what happens when this amount of charged electron goes down, voltage goes down, meaning the potential difference of charged and uncharged electrons goes down. This is the difference. Now, to keep the things simple, I just want to explain you one circuit design, which is a very simple one. So we have a source uh, here. It's an electricity source. It could be any source, but I have chosen 12-volt source, which is a battery source. To protect this whole system, we must install a fuse here. So fuse always goes on this side, and this is our positive side, and which goes to ground is always our negative side. So we always put our fuse on positive side. So this fuse could be of any size, but depends upon the size of the electrical equipment which we are using. So if this electrical equipment we are using, say for example here we are using a bulb. So if this bulb is 100-watt bulb, then this fuse will be a bigger one. If it is just 10 or maybe uh, 10-watt bulb, then this fuse will be a smaller fuse. So this is the basic system of any electrical system, in which to protect the whole electrical system we must start with fuse. How we rate the fuse, I will tell you how to rate a fuse in my coming videos. I will explain how we decide the size of a fuse depending upon the size of our electrical appliances. So but right now I'm just trying to explain you what is the basics. So always start with the fuse, a resistor, and a bulb. So why do we need resistor? Resistor is a kind of hero in our electrical designs. Why it is hero? Because electricity starts from here, electrons are traveling at full speed. Fuse is doing nothing here. Fuse is not trying to stop this electron flow. Okay, these electrons flow at a very high speed. So if they will hit this bulb at that high speed, they will fry up the bulb. They will These electrons will hit the bulb at full speed, they will fry it up. So resistor works as a speed breaker, and resistor is also useful in designing our electrical circuits, where we have to control the flow of electrons to one branch, and to the other branch we have to increase the flow of electrons. So say for example, if I attach one branch here, one branch here, and I want to keep my electrons flowing in these branches, let